Thank you.
Okay.
All ears. Go ahead. Thanks.
Okay, perfect. Yeah, warm welcome from my side, from sunny Austria. For the next hour, we'll talk about Databricks and how you can use it with your, let's say, SQL background or SQL developer. Yeah, before we start, a little introduction to myself. My name is Gerhard Brückel. I'm living in Austria, and I've been working with Microsoft data platform, SQL Server, etc. for more than 15 years actually. Originally coming from data warehousing, BI, and I recently transitioned to data engineering with big data processing, Spark, Databricks, and that's also the reason why I thought this PaaS may also be interesting for others, and wanted to give you like a brief introduction of how you can use your SQL skills also in Databricks and well, big data processing. If you have any questions, you can always reach out to me either via Twitter or via email. You see all the contact details here. I'm also one of the organizers of the SQL Saturday in Vienna that it was just mentioned before, and also for the PaaS community in Austria that was also mentioned before. I'm working at a company called Pico, which is focusing on data platforms and AI and analytics. So like Databricks is our, let's say, bread and butter tool or our tool of choice when we build those solutions for our customers. And besides that, I also do a lot in the community, which is like speaking at events like this, speaking also at conferences, blogging. You find the URL to my blog at the top, and also developing some community tools, open source tools like PowerShell modules and the Visual Studio Code extension for Databricks. And I was also developing this connector in Power BI to natively read Delta Lake tables, which you will also learn about in this session. Okay, so what are we going to do? Well, first of all, as I don't know the background of all of you, I'll just give you like a brief introduction into Spark and Databricks, what it actually is, and also some overview on how it is actually different from a regular relational database management system or SQL Server. And then we'll already start diving into SQL as Databricks, have a look into Delta Lake, which is actually very important for a data platform nowadays. And if we have time, we will also look into advanced SQL techniques, like user-defined functions, user-defined aggregates, etc. Yeah, so what is Databricks? What is Spark? Let's start with Spark. Spark itself is an open source cluster computing framework, which means you just take a bunch of machines, of computers, virtual machines, and connect them into a cluster, and then use all the different nodes to process one big job, basically. The general idea behind this cluster processing is that you can basically scale linearly. So like if your job takes, I don't know, like 1 hour on a 2-node cluster, you can just increase the cluster size to 4 nodes, and then it ideally the job should only run like in 30 minutes, like half the time if you double the nodes. So that's like the basic idea behind the cluster computing framework. And as I said, like it's built for speed and scalability, but also for ease of use and extensibility, which means that you can use Spark with multiple different languages, being Java, Scala, Python, R, and SQL at the moment. There is also a C# support or C# API that you can use, and it's also constantly growing. So you could basically use any language that you want also on Spark if you write the right wrapper for it. And you can also combine those languages, so you can write code in Python, integrate it into your SQL code, and this making it really, really easy to use, and also offers great potential for writing your own extensions. So that's really powerful. When it comes to Spark, Spark out of the box comes with different features. One of them being Spark SQL, which is the whole SQL engine and data frame engine. But there are also other different aspects of Spark that I just want to mention briefly, which would be Spark MLlib, which is like a distributed machine learning library. And then there is GraphX, which is a graph database that's also running on the cluster. And there's also Spark Streaming, which is like stream processing, or actually it's micro batching within the Spark framework. All those use the same Spark core engine. That's basically the cluster, which then has some cluster management below, which can run on Yarn, Mesos, and its own built-in cluster manager for to manage all the nodes and the commands. Yeah, so basically you have like Spark, you have all those different features baked into this one tool, which makes it really powerful, especially for AI and machine learning, because you can just use the very same platform for your data engineering, for your data provisioning, and also for your data science and machine learning stuff. So there is like no hard interfaces or no transportation of data when the data scientists want to use it. You can just use the very same tools that you do. Okay, so what is Databricks now? Databricks, so as I mentioned before, Spark is basically an open source software. Everyone can use it. It's owned by the Apache Foundation. And Databricks is basically like the, let's say, commercial the commercial solution for it. What you need to keep in mind is that the people that originate or are the main contributors of the Apache Spark software are also the people that are basically running Databricks. So Databricks is still the biggest contributor to the open source Apache Spark. But what's important here that the newest features are usually first released on Databricks, and then like 1, 2, 3 months later, they usually also make it to the open source Spark. But if you want to stay up to date with Spark, then Databricks is usually your best bet, because the features are released there at first. So also important to mention is that Databricks itself is cloud only, so you cannot install it like locally. You need to use one of the 3 major cloud vendors, being AWS, Azure, or Google Public Cloud. Yeah, and in there it's basically like a platform as a service solution that you can just like subscribe to, and then it will basically spin up a workspace for you that you can use. Okay, now what are the main differences between big data and Spark processing in comparison to traditional relational database management systems? So for, let's say, I will mainly use Microsoft SQL Server as a reference, because that's the tool that I use the most. So if you coming from a SQL background, you probably know that the SQL Server itself is it's basically encapsulated as one tool, right? So there is like no external access. Everything that you need to do, that you can do, needs to go through SQL. So whenever you run a command or write data, it always goes through the SQL, and then persists the data in your data files, in the MDF, NDF, and the log files. One of the main problems here is that you have like quite limited resources, and there is like no real scale out solution. I mean, there is some like Azure Synapse that scale better, which use a similar solution as Spark does with massive parallel processing. But for a regular SQL Server, there's like no scale out. You can just scale up and to a certain point, but once you reach it, you're basically stuck there, because there is some limits in CPUs, there is some limits in memory, etc. If you've been working with data warehousing and SQL Server in the past, you probably encountered that there's always an issue if you're running ETL processes, and your processes may take longer than, let's say, 9 AM in the morning, and people already start working and using the data warehouse. And then you have like this conflict between like the user queries and the ETL processes, which is definitely not what you want. So that's one of the main problems. And also, as I said before, the data is only managed and only accessible via SQL. So no external tool can just read the MDF file. So it always has to go through the SQL Server process. In comparison, if we have a look at big data and Spark, there is one very important concept, which is the separation of storage and compute. So basically, the data resides in the storage, and if nothing happens with the data, I don't need any compute, so I just like pay for the storage. Once I need to do something like run an ETL process or query the data for some analysis, I basically spin up my compute engine, run my query, and once I'm done with all my work, I can just shut down the compute engine again because it doesn't persist any data. It always loads the data from the storage, which makes the whole solution usually super cheap because you most of the time just pay for the storage. Also, you can attach multiple storages to your compute engine, also to Databricks in our case, and you can also have multiple compute engines accessing the same storage. So it's super flexible and it scales linearly. So you can have like any number of storages, you can have any number of compute engines. Obviously, you need to take care of things like if one cluster is reading data, the other one is writing data. So stuff like transactions, something that you need to take care of. But we'll cover that later. When it comes to specific terms in those two worlds, I prepared like this little comparison when we're talking about the server in SQL, what it is in big data and Spark. It's actually more or less the same. The biggest difference is probably the table, what an actual table is. So a table in SQL is for you, it's just a table. You don't have more access to the data underneath, etc. However, in Spark and Databricks, it's basically a definition of location where the data resides and the metadata. I will also have a look at this later. One very important distinction between the two is that there is no concept of an index in Spark. So a single row lookup will never be fast in Spark, let's say. Okay. For programmatic stuff like stored procedures, UDFs, and views, you have very similar capabilities in Spark. So you can just, instead of having a stored procedure, you can just have a notebook that reads and writes data, that returns data, that takes parameters as input, etc. The concept of UDFs, user-defined functions, and views is just the very same in the two. Okay, so let's have a look on what SQL with Databricks actually looks like. First of all, usually most of the projects that I start with, there is a decision whether the customer wants to use Databricks or whether they should go for a, let's say, SQL database. There are some reasons where you should definitely go for Databricks. There are also very good reasons to go for SQL. I just mentioned here some that favor Databricks, let's say. So like if you want to have like scalability, or like linear scalability and flexibility in terms of structured and unstructured data. So if you, I don't know, like want to process binary data or even JSON as a semi-structured data, I guess you all know that it's usually a big pain if you want to process JSON data in, for example, integration services or in SQL Server in general. Also, you can use Databricks and Spark if you want to use an open standard and want to avoid like a vendor login, especially for bigger companies. That's often a good reason to go for Databricks and Spark. So they have like no dependency to one vendor, but can more or less just easily move from, let's say, AWS to Azure. The main reason for me usually to use Databricks is because it's like the same tool that works for a wide variety of workloads. So you can use Databricks for your ETL jobs, for your data engineering. You can use it for the data scientists and machine learning, and you can actually also use it for BI and reporting to some degree. Yeah, and as Databricks is a cloud-only solution, it makes a lot of sense if the data that you're reading or that you're loading into your platform is also based in the cloud, so that you don't have to have this back and forth between cloud and on-prem all the time. Yeah, important part here, especially when comparing SQL to Spark. Spark is not built for highly transactional systems. So it's mainly used for batch processing, like once a day, maybe a couple of times a day, but definitely not for, let's say, a million single transactions per minute, for example. So that's definitely not what Spark and Databricks are built for. They are built for analytic purposes, and yeah, you should stick to that. So what happens when you actually run a query on Databricks? So the SQL looks quite similar to what you're used to from SQL Server. It's basically select star from table. Okay, so what happens is the query is sent to Databricks. It's validated against the metadata store, whether the table exists, the columns exists, etc. Once it's validated, it's basically querying the storages for the actual data, does the processing, and as a result, you can either like return the results to the client, to the caller, or you can also write the results back to the same or to another cloud storage. So that would be like the classic ETL pattern, where you load data from one cloud storage, do some transformations, and then load it back to another cloud storage. So the Hive metastore. So when we're working with Databricks, there is always a metadata catalog in the background that keeps track of all the SQL objects that are part of our Databricks workspace. So this means tables, views, and functions, basically. For each of those, especially for the tables, the Hive metastore needs to know the location of the data. It needs to know the structure of the data, meaning which columns are in there, which format it is. And with all this information, it can basically present like a SQL table, or present a SQL table on top of the data that resides in the storage. It's important to note here, all the tables that you create in Databricks and in Spark, it's basically just references. So it's just like an interface or a view layer on top of the data that resides in the storage. Okay, and obviously those have to match. So if you create a table and say, okay, my table has 5 columns, but the data underneath has 6 columns or only 4 columns, then it will not work. Okay. Okay, so as we have this distinction between the processing and the storage. So what happens when we basically run a select statement? Databricks takes the location that's defined for the table, then which you run the select statement. In this case, we're using CSV files, just for simplicity. It's actually reading all the CSV files that are in that particular location that the table points to, reads them, processes them, and returns the result. That's pretty straightforward. If you do an insert, what happens is that it's basically just creating a new CSV file or a new file in your storage. And once you do another select, the next select will just pick up the new file, and well, your results will contain more data. Okay, so that's pretty easy and pretty straightforward for inserts. But as you can imagine, for an update or a delete of especially of single files, that can become quite complex to code. So this is not natively supported, but there is also a solution for that, which is Delta Lake, that I will cover later in more detail. In terms of supported SQL features, I don't want to go through all the details here. There is like full support for the whole ANSI SQL stuff. There is no support for, let's say, vendor-specific stuff that, I don't know, like only exists in SQL Server or only exists in Oracle. That's usually not supported, but could also be that it is. So for example, common table expressions that you know from SQL Server are actually supported in Databricks. But the important part here is that all the standard SQL is also supported by Databricks. Besides that, you also have some additional features. So in Databricks, you can actually have complex data types being structs, maps, and arrays. And you can also nest them, which is not possible, or at least not really recommended for SQL, so that you have like one column that contains multiple values. That's not a good practice in SQL, but it's actually perfectly fine in Databricks. And you also have like dedicated functions to process this data. Also, you can define caching on your own if you want to. And most of the code that you write in SQL, you can also use in the other languages that are supported by Spark and Databricks, being Python, R, Scala, and Java. Okay, so you can basically just write a SQL statement from your Python code that leverages Spark, and then continue with Python or continue with R, Scala, or whatever. Okay, so let's have a quick look what it looks like. So what we see here is basically the Databricks Workspace. The first thing we need to do is to basically connect our storage. So what you do need is the location of your storage. In my case, I'm just using a blob store, and I do have a read-only shared access signature, which allows me to read from that particular blob store. Then I can create a mount point. And can start querying the data. Okay, so that's my blob account. It contains basically AdventureWorks, which I guess most of you are familiar with. So you have like a dimension account, dimension currency, dimension customer, etc. So that's like the connection to the storage. Next part would be to creating the SQL tables and the database. So you can have like a create database statement. And then that's what a create table statement looks like for CSV data, for example. So I have my CSV files. I can have like a wildcard saying all CSV files in that folder. I need to define the format, the columns. I have like account key as an integer, parent account key as an integer, account type as a string, and so on and so forth. There are some additional options, especially for CSV, whether the file contains headers, whether we want to infer the schema, escape characters, quote characters, and so on and so forth. Once I have this set up, I can just run a very simple SQL statement, select statement, select star from my table, limit 10, which returns the top 10 results, top 10 rows from the CSV files that are actually located in this location. Okay. I have basically done this for all the tables in AdventureWorks. I just wrote a little script, so we can start working on this. Yeah, for the select part, as I mentioned, like all basic statements are supported. You can have like a like filter. You can obviously do joins. You can visualize the data already in here, which is also super convenient. You can have sub-selects, group by, aggregations. Yeah, just as you would know from your SQL database. Also, more complex stuff was group by and roll up or grouping sets. It's also supported. The cube function. And you can also use window functions. Okay, so even though those are perfectly fine supported in Databricks, there should be no major blocker when it just comes to writing select statements, unless, as I said, like you use any very vendor-specific commands on your SQL engine.
Gerhard, can you ask a question?
Yeah, sure.
Well, actually, when you're creating those tables, where it's reside, is it in the blob storage?
Yeah. Pardon?
I'm sorry, someone's mic is on probably.
Yeah, so the data resides in a blob store.
Okay.
We go back. So for dim account, for example, we do have one CSV file in there. And whenever I query the dim account table is actually going to the storage account, reading the CSV file and processing it and then returning the results. Does that answer the question?
Thank you, go ahead. Thank you.
Okay. Okay. Yeah, I mentioned that besides the standard functions that you know from SQL, there is also some advanced or extended functionality, especially when it comes to complex data types. So what we can do is we can run a query like this, which basically the group by, which does a group by of my fact internet sales and lists all the products per customer as an array. So it's really like a complex object that's an array, and you see for each customer which products he bought. And now you have other specific functions like this contact VS, or you could also do like a slice or top or first, last, whatever, of this array, and process the data. Okay. What I did here at the query above, I just like converted to an array, and then again concatenate it and have like a comma as a delimiter. And also there is like specific functions for filtering. So for example, you can say, okay, I only want to see customers that bought the product 478. So those are like extended functionality that come with Spark and Databricks that are usually not available in regular SQL engines. Yeah. If you ever had the requirement to show like the latest version of a particular product, for example, in this case, we have like a product key, and this one changed over time, multiple times over time. If you want to have the latest value only, what you would usually do in SQL, you would probably do like either a max or a row number and then join it back, or have like this the window function. What you can do in Databricks, you can basically run a max on a struct, like on one of the complex objects, and adding like the ordering column as the first argument. And then it basically takes the max start date and also returns the star as all the information. So this would basically return the data for the last entry for this product alternate key. So that's those extended capabilities that you have when working with complex and same structured data. Besides that, there is also functionality to read files directly. So in case you have not yet created a SQL table, you can also directly read CSV files. Okay, like this. In this case, if you do it like this, you cannot really specify the options that you have like header rows, the data type, etc. So it just like reads the data as it is. To do this, to make this work, you can use some Python code, saying, okay, read the data from the same location, specify the additional properties, and then basically say, okay, expose this data frame that's created here for me with this additional options, and expose this data frame as a SQL table. Okay, if I do this, I can then just run a select on the SQL table, and I do have all the data types, headers, etc. Set correctly. Yeah, let's also have a look at JSON. So the very same also works for JSON files. So if you, yeah,
no, I can't seem to ask a question. There's no place to ask. Chat window.
Yeah, I don't know yet. I also don't see a chat window. So yeah, if you have a question, just go ahead and ask it. So yeah, so what's the question?
Please ask the question if you have any question. I was putting actually the text in the chat. I thought people are able to see it, but it seems so no one able to see the chat, right? Okay.
No.
Okay. Yeah, this is interesting. But now, please, unmute yourself and speak up if you have any question, please.
Yep.
Nabila, do you have any question?
Yes. Would a recorded version be available?
Yes, it will be available after the session. Yeah.
Thank you.
Okay. Cool. Not really related to the talk yet, but okay. Yeah, you can also use this approach of specifying this from then data format dot and then just specifying a path for JSON files. If you have like a more complex JSON as the one below, which is like just an extract of my blog and some tags and links and related posts, etc., that are in there, you'll realize that the JSON is quite a complex one with nested structures in there, nested arrays, and so on and so forth. So it's not something that you would easily be able to analyze in SQL. But here it's basically just one line of code. So I can just run a select on my JSON file, and it basically, if there is an array in the JSON, it will just expose it as an array in my data frame here. If it is a struct like this, so like there is an array of struct elements in there, it's also just displayed here, and I can also access them accordingly. So with the functions that we've seen before. So this would be like a more complex query that basically just takes all the posts that are published in year 2019 that have a tag direct query and are related to the tag data or contain the word data. So that's just based on top of one JSON file. That's yeah, quite complex. Okay, so that's like capabilities that you have when working with semi-structured data in Databricks, which can be super convenient already. Yeah. Okay, so that's it for the regular SQL that you can use in Databricks. But that's just for analysis for yeah, basic select statements. And as you've seen before, once you want to do updates or merges, it's usually not easily supported by Databricks, and that's where a new storage format called Data Lake comes into play. So Delta Lake also, similar to Apache Spark, is an open source project, and it basically defines a storage format that can be used in combination with Spark and a data lake. It brings some features that you probably know from SQL to your Spark environment. Most important ones are probably that it's ACID compliant, so there is like transactions in there, which means you make sure that either your transactions are processed at all or not at all. It's durable and so on and so forth. The the feature it's using is optimistic concurrency control. It's basically similar to what what's it called? The in-memory SQL Server feature for the row store. Hackathon it used to be called, I think. It's basically the same concept. So it's not locking a table, but just checking before it's actually doing the insert or the update, whether the data has been changed in the meantime. Anyway, also it fully supports update and merge statements. So even if you update like a single row in a particular file, you don't have to worry about the management of the files. You just run your statement and Delta Lake takes care of which files it has to modify, which files it has to rewrite, and so on and so forth. There is also a feature called time travel, which is similar to temporal tables in SQL Server. So basically each update is tracked, and you can go back and say, okay, what was the value of a particular row before my update, for example. It also has features for schema enforcement and evolution, so that you can only insert data into a Delta table that is compliant with the schema of the Delta table, or you explicitly define schema evolution. So if you dynamically want to add new columns, so for example, if you have like a dynamic data source that frequently adds new data and new columns, and you don't want to change your ETL each and every time, you can just have like schema evolution, and then like this new column, for example, is added automatically to your table and to your data pipeline. Also, Delta Lake supports batch processing and stream processing, so you can stream from a Delta table and you can also stream into a Delta table. It is also used very frequently, especially for IoT scenarios. And the most important part is that it's obviously 100% compatible with Apache Spark. So that's why it's used so often. So what does it look like? It's basically like a folder that contains everything that's relevant for your data or for your table. It's basically a table. So there is the data in there, it's metadata in there, and it's also the transaction log or the Delta log in there. Usually those tables, those Delta Lake tables, reside on a data lake, but you could also just take the Delta table, copy it to your USB key, plug it into another PC, and read it again from there. Okay, so that's just super flexible and can be reused or used by multiple readers and writers anytime. As you've seen before, when defining a table in the Hive Metastore in Databricks using this create table statement and defining all the columns, if you're actually referring or want to mount and load a Delta Lake table, the only thing you need to do is basically specifying the location, because everything else, the column definitions, the partitioning columns, the data, etc., is already part or is stored as part of the Delta table. Yeah. So the Delta log, that's used for transactions. So each and every transaction that you do is basically recorded as a JSON file. Okay. So when you do an insert, when you do an update, when you do a delete, when you do a merge, each of those would be like a separate JSON file containing all the information that's necessary to process the data. After 10 transactions, by default, a so-called checkpoint file will be created, which is a paquet file, and that contains all the previous transactions, basically. So the reason to have this checkpoint file is just that you don't end up with millions of JSON files, but you have like one checkpoint file, and then only up to 10 JSON files that contain the transaction after the last checkpoint. And yeah, this Delta log is used for concurrency control and also for this time travel feature, as we will see later. Yeah, if you want to create a new Delta table, the syntax is very similar. to the one that we've seen before. However, if you want to create a delta table on top of an existing data lake that you've mounted before, the create table statement becomes quite trivial because you only have to use this using delta and specifying the location where the data actually resides. And as I said, like the rest is managed by the delta lake table itself. So let's have a look on what actually happens when you run certain SQL statements on top of your delta lake table. So on the left side, we see a delta lake table that contains 3 rows. And it is already stored as a delta table. So there is one transaction, the transaction 000.json, which basically said, okay, one file with 3 rows has been added. That's why you see this add at the left side. Now, what happens if you run an update statement? It's actually creating obviously a new transaction. It is removing the old file from the delta table and adding a new file to the delta table. Okay, so you now end up with 2 Parquet files, each containing 3 rows, but only the second one, the last one, is part of the most recent version of your table. Okay. Similar, what happens if you run a delete? If you delete, for example, the PC from your table, what happens is it is actually removing the whole file. And what might be a bit surprising, it's actually creating a new file, but the new file only contains 2 rows anymore. Okay, so even though you run a delete, you're actually creating more files, which is a bit contradictory, but it's just related to the fact that you want to have like this time travel capabilities. Okay, so if you want to go back to the data as it was before the delete statement, you at some point have to keep the previous file. It's not done on a row level, it's really done on a file level. So after those 2 transactions, our delta table already consumes 3 times the space that it actually would, or the latest version of the data would consume. If you run an insert statement, it's pretty straightforward. It's just adding a new file with that one row that you inserted. So you end up with 4 files as part that belong to your delta table. To reduce the size of your delta table again, there is a command called vacuum, which basically deletes all the files that do not belong to the latest version of the table. So if I run a vacuum on the table, it removes all the files, or like the first file and the second file, because they are not part of the most recent version of the table anymore, and only keeps the file 3 and file 4. File 2 containing the initial 2 rows, and file 4 containing the row that we inserted. The data itself did not change. Okay, so the regular user will not recognize this. Besides the vacuum, there is another operation which is called optimize that basically merges small files into a bigger file. So instead of having 2 files, one with 2 rows and one with 1 row, the optimize produces 1 file that contains all the 3 rows. Which is much better once you actually read the data. So for big data systems, it's actually can be quite painful if you have a lot of small files. So if you run this optimize from time to time, it basically tries to create files between 250 megabytes and 1 gigabyte, which is much better for reading and for later analysis of the actual data. And yeah, that's high level how Delta Lake works. As you have seen, basically every operation that you do, even if you just do a delete, it's actually creating more files. Okay, so you really need to be aware of this. Otherwise, you end up with storage costs that would just skyrocket. You definitely always want to have some regular vacuum job in place that, I don't know, like once a week, remove all the unnecessary files, unless you want to keep the history or need to keep the history. Yeah, be aware of the storage costs.
Gerhard, there is a question from Mikhail. Mikhail, you can
Yep.
speak up. Yeah.
Yes. Hi, Gerhard. Could you maybe tell more about difference between optimize and vacuum? I'm just trying to wrap my head around it.
Okay. So on the left side, oh no, that's what I wanted. On the left side, you basically see, I can use this laser pointer thing. So this is like the data that's there before the vacuum. So we have 4 files, and basically the data from the first file, then the second file is not used anymore. So if I run a select star from my table, it's actually returning 3 rows, those 3 rows, okay, which are made up by the 2 rows from file 3 and the 1 row from file 4. Okay, so for a regular query, for a regular select statement, the file 1 and file 2 are not used. Okay, it's just like historic data or old data. And vacuum basically removes this old data in order to save space, save storage space. Okay, so everything that's not part of the most recent version of your Delta table is removed. On the other hand, if you have a look at optimize, optimize basically ensures that small files like those, which contain only 2 rows and 1 row, are basically combined into one file again, as I said, to improve performance.
Are these operations online operations, or they put some kind of maintenance cost, so it takes at least offline querying for some time?
It doesn't take anything offline. It's recorded as a transaction. So especially the vacuum part is totally independent of everything, because it's just removing data that's not used anymore. Optimize can potentially conflict with other inside operations.
My question is in line, like, for example, when we do partitioning maintenance in a normal, let's say, SQL Server sense, you can completely rebuild partition on the side and then just swap the partitions. Pretty much it's metadata operation. I'm just trying to find the analogy here.
You can also run an optimize on a partition, so you can also partition your table. You can run an optimize only for a specific partition. And as soon as the optimize is done, basically this entry is written to your Delta log, basically removing the old files and adding the new file. And every future query after the optimize will just read the new file.
I see. Thank you.
So it's not blocking. It's not blocking your processing. Okay.
Thank you.
Yeah. Well, we can create a lot of files. We talked about, we briefly mentioned that there is this concurrency control, which uses optimistic concurrency control. So it can happen that 2 people update the same table or the same row at the same time. One of them will obviously get an error, and if you get an error, you have to handle it on your own. So ideally, you write all your code to be able to manage those conflicts. So comparing this to SQL again, if 2 people are processing or updating the same row in SQL, usually one will be or like the first one creates a lock, then does this operation, and then until the first operation is done, the second one is blocked. And once the first operation is done, the second one can continue. That's slightly different here in Delta Lake, which uses optimistic concurrency control, which, well, first assumes that the data hasn't been changed, but if it has changed in the meantime, it will raise an error. But as I said,
sorry, there is one more question, Mahesh. You can ask the question.
Thanks, Paul. My question is, if you want to use the Delta Lake on this like in the Databricks, do you need to specify? You need to call anything in the notepad, or you just by default it will be a Delta Lake?
Yeah. So I think with version 7.3, Delta Lake is the new default storage format. So if you just do like a create table or save some data frame as a table, it will use Delta as the default storage format. So unless you specify anything different like CSV, JSON, or plain parquet, it will use Delta Lake.
So that means that you don't need to import anything. It just
no, it's built in with Databricks. You don't need to worry. You don't need to run any import or anything. You can just use it.
Thank you. Okay. The second question: is it possible to share this deck later this session?
Yeah, sure.
Thank you. It was a good presentation.
I guess we can upload it somewhere. All right.
Yeah, we generally upload to GitHub, and I share the link to all the audience. Yeah.
Thank you, sir.
Okay.
Bye.
Yeah, there are some more details on optimize and vacuum. Basically, you can specify filters for the optimize. It's usually a partition filter. So if you only optimize like a particular partition, but optimize will also take care that it doesn't re-optimize data over and over again. So it knows the data has been optimized and hasn't been changed and won't re-optimize it again. There's also a feature called set ordering, which basically orders the data before you actually write it, which can improve data skipping capabilities, so that based on the metadata, the query engine already knows that a particular value will be in one file or will not be in one file. From my personal experience, I haven't really seen a lot of improvements for the ordering or using this set ordering. But yeah, it may very much depend on the use case and on your data. For the vacuum part, you can use just use vacuum and the table name, which will remove all data that has been outdated for more than 7 days. But you can also define a custom retain value. Then you can say, okay, remove everything that's has been outdated for more than 1 hour or 0 hours or 30 days, whatever. And you can also run a dry run, which will just tell you which files it will remove. Yeah, let's also have a little demo on this. Keep a link annotation. I don't know. Okay. Anyway, Delta Lake. Okay, so that's also coming back to the question before. That's like the most easiest way you can create a Delta table, and you don't need to do any imports or anything. You can just do a create table using Delta and then as select. And so we take data from our CSV files and store it in a different table, which is then stored as a Delta table. That's the easiest thing you can do. Then we can also have a look at the data that was generated. It did generate our Delta log. It created one transaction in this one JSON file, and it added one parquet file. This parquet file contains all the 600 rows that are in the stem product table. Well, you can obviously query the table. And I also want to show you how you can use a merge. So what I'm doing here is basically I'm creating a temporary view that increases the standard cost for mountain bikes by 1.2. Okay, so that's the table that I want to use. That I want to use for my update. And then I can just say I merge into, very similar to SQL, merge into my Delta table using my view, join it on the product key. If there is a match, then update the standard costs. So that's really very, very similar to a merge statement in SQL. And works the same way. Let me just execute everything from top. So that, because I was playing around with it before and I just don't want to mess up anything. Okay. Now, as we've learned with the merge statement, it's basically an insert and an update. So it's creating a new version. And we can always use this time travel capabilities to go back in time and see what a particular value was before the merge statement and after the merge statement. Okay, so if you do not specify anything, it is basically using the latest version of the table, meaning including the merge statement, including the update. But I can also say, okay, please show me the initial version, which is version 0 in this case, and combine these two. I should be able to do this. Ah, okay. I'm running a vacuum afterwards, that's why it's not working. Okay, so we do have the current version, which has the updated standard cost, and we also have the previous version, which has the old standard cost, like version 0. And yeah, so that's some very easy way how you can compare data before your ETL process, for example, and after your ETL process. That's super convenient, actually. If we again have a look at the files, it created a second transaction. It created a second parquet file. Yeah, so that's what we expected. We can also have a look at the history. I'm just generating some more operations here. So I'm doing another update and doing another insert. And then we can have a look at our transaction log, basically. And it will tell you, okay, the initial table was created with a create table, a select statement. Then we ran a merge statement on the product key. Then we ran another update on another product key, and then we run another append. It also adds some more information on what actually changed. So target rows, number of files that is written, number of files that has been copied, etc. So that already provides a lot of information. And you could use any of those values, version 0 to 3, as part of this version as of statement. Instead of version as of, you could also use a timestamp as of to show it the state of a table at a particular timestamp. Okay. Yeah, if you run an optimize, this will also show up in the history. You will see this optimize statement here. If you run a vacuum, it will basically remove all the rows that are not necessary, or all the files that are not necessary anymore. And so if we would have a look on our data lake again, you would only see one parquet file anymore. Okay, however, you would still have the history of all the transactions that happened. Okay, so we had initially we had 8 transactions, but we only have one Delta file. So if we now try to query the initial file that was created with the create table as statement, the file doesn't exist anymore because it was deleted using vacuum. And now you obviously get the error message saying, okay, the file that was referenced doesn't exist anymore. Yeah, schema enforcement and schema evolution. If you, for example, consider a delta table or a SQL table that's based on CSV files, you could just technically add any bunch of CSV files into that folder. And the CSV files not necessarily would need to have the same schema. If you would try the very same in a delta table, it will complain that not all columns, or that you didn't specify enough columns, or that you specified too many columns, like this one. Okay, so that's just like a safety measure to make sure that your data in the delta table doesn't get corrupted. You can also have like this automatic schema evolution, which allows you to automatically add new columns if the source, for whatever reason, suddenly has new columns too. Okay. That's actually the main part. I would have some more slides and demos on advanced techniques, mainly focusing on user-defined functions. I don't know, Paul, should we continue or should we stop here?
I think it's good to stop here, because the reason is, people it's a working hour, so lunch hour has been over. So no, but this cloud will be definitely helpful. They can go into it, and if there is any question, there's always they can reach to you.
Yeah.
So, yeah.
I can actually also provide the notebooks. All of them should be you should be able, like if you have like your own Databricks environment, you should be able to run all of them. It's just they're only using a read-only shared access signature to my blob store. So you can just use them, and I'll provide a link so that you can also put it to the Git repository.
Oh, that would be great. If you're done, Goret, so I can ask to hold that in this. If you have any question, you can unmute yourself and ask the question. I mean, I don't know with the teams. It's the third time that's happening where I'm not. I see this as chat option has the issue.
I know that this is usually related if people that are joining are not part of the same tenant, which is
okay,
or not joining from the same tenant, something like that. But yeah,
this is a bit weird because it's more engaging, right? When people can chat and
obviously.
But I'll try to fix it, because I thought, okay, maybe next time I'll see if this again happened, but it's like now third time. I must have to fix it. Sorry for that.
So are there any questions left, or any more information that you need? Then feel free to just unmute yourself and ask.
Yeah, Mikhail, please.
Yeah, follow-up question about versioning and everything else. In data warehousing, we all know, yes, there are slowly changing dimensions. So do you still continue to build your version of the row in like normal ETL sense, where you have all the indicators that this is not a current version of the row, or you switch to these new techniques, though you may, catch yourself in a situation where you vacuumed it and removed all the versions? So what's your take on it?
I would still use like the old school approach and do the versioning on my own. For the same reason why I would probably not recommend using temporal tables for slowly changing dimensions. So like if you do it on your own, you're in control. And I think that's the most important part.
Thank you. That was in line with what I was thinking.
Yeah. So it's a nice feature, but it doesn't solve all problems, obviously.
Will it make sense, at least for the, let's say, for the current running day, to have some versions if there is some data churn in your fact table, so you keep the versions just in case, and then you kind of vacuum at the end of the day?
Yeah, that's what I would do. So the default for the data retention is 7 days. Which is usually quite fine. So for example, if you have like some ETL jobs running and for whatever reason it's failing, or some of them are failing, some are not, It's always convenient that you, for example, can go back like at least one day or the previous run and see, okay, what was the data before? How was it changed? And you can also do like a rollback and say restore version as like the previous version. So it basically just throws away the changes, which is also super convenient. So I would definitely recommend to have the time travel feature turned on, but don't use it for data retention, let's say.
Thank you so much.
Yeah, sure.
Would you mind to stop sharing the screen, Gerhard? If you can stop sharing the screen, because I can see my. Sure. Yeah. Okay. I have actually a few questions. One or two questions. So, for example, actually, we learned that how we can use that the very similar way how we make the query in the database. We can all do in the Databricks. But actually, since these things can be done in SQL database, but when actually we choose to do that in the Databricks.
I had one slide about it at the very beginning. So there are some reasons, mainly when it comes to scalability and also when it comes to semi-structured data or unstructured data, which usually doesn't work very well with the SQL database. So these are like main reasons to do it, or to use Databricks over a SQL engine.
Okay.
Also, if you basically already have like all your data in the cloud and you want to have like you do your analysis and data processing in the cloud, then that's also one reason why I probably go for Databricks, not for SQL. But there are also very good reasons to actually use SQL. So for example, if you have like transactional processing, obviously, but also if you have like scenarios where you need to provide like single row lookups very often. So that's just not something that works well with Databricks.
I have my second question, which is like, since you were working with the Databricks and you're expert in this domain, how do you find out the performance was compared to using the database engine versus the reading the data or loading the data in the Parquet? What is the trade-off there? How do you find them?
First of all, you will never have like sub-second latency queries on Databricks. That's just not how it works. Even though if you use caching, there is always some overhead, like your query has to distribute it on the cluster. The nodes have to calculate the results. The results have to be returned to the driver, to the head node, and then the head node basically can display the results to you. That's just not something that works in 1 millisecond, for example. However, especially with growing amounts of data,